Get out your note sheets. Just get out some regular,
What happened was,
okay, does anybody have a piece of paper we can use? Take a picture of this with your phone.
I have the draft.
And then
Oh wait, I think I already started this. Didn't we? Or did we do the other one?
we did this. I think we're ready for this one. Are we ready for this one?
Should I take a picture of this side too?
Yeah, go ahead. I don't know how far we can get. Okay, are you taking notes? Okay, I need to know where I stopped. Down here? Yeah. I thought we were ready to start here. Yeah, okay, so go over to the shelf and get some graph paper. Okay. Alright, so before we do the graphing, which is where we're starting back in, nothing new, just more of the same. We'll practice, practice, practice. Before we do that though, I want to do one more of those big inverse problems like you did on your little group quiz. Just to review those steps, and it's been several days. Alrighty? So this is not on your note sheets. You'll have to do this on maybe your green quiz paper or another sheet of note paper, something. We're going to do one quick review problem, and it's going to be this. The directions are going to say f of x equals 8x minus 2 over 5x plus 3, and your job is to find f inverse. Okay, this is what you did as a group, or in your little groups, last time we were together. Alright, so we're not in the note sheets, we're not on the graph paper, we're doing this to kind of get refreshed a little bit, and then we're going to jump in and do these graphs. Another sheet of paper, yeah. Or the back, maybe the quiz I just gave you, if there's room on there to do it, I don't know.
I got a sheet of paper.
You're at the bottom.
I got it.
Okay.
What you need? Paper?
Well, then you have a sheet of paper right there.
Don't need a sweat.
Alright,
Okay.
thank you for helping each other out. Alright, so who remembers step 1? Here we go, Althea. Do you remember it all about how I even started this problem? Switch the x and the y. Now, Althea's remembering that this is the same as y, so she's just going straight to this step, which is absolutely fine. This is the same as y, so she put in an x for it, and then she's got y's in here. All right, who remembers the next step? Colleen. Over here to the other side and distribute it times the x, right? So we're going to bring that 5y plus 3 over here and, and distribute. So we have 5xy plus 3x equals 8y minus 2. Very good. All right, now this is the big step. Deshanti, what do we do now?
Get both the y's on the same side.
Move things around so that all of the y's are on the same side. And all of the other things are on the other side. So we're going to move the 8y over here, move the 3x over here. Now, why did we do that, Chris?
To get both y's on the other side.
And what was the purpose of getting y's on the same side? What will I do next?
You will, hold on, it's early in the morning, trying to get my brain together.
Yep.
You take the y out.
Take the y out. We put them on the same side so that we could factor them out. And then there's one more step. What is the very last step to the problem?
Divide by what's in parentheses.
Divide by the parentheses. So in the answer blank, the question said, what's the inverse? You will say negative 3x minus 2 over 5x minus 8. Does everybody vaguely remember that? Okay, guarantee test question will probably show up on another quiz sometime. Alright? Keep that in mind. Okay, good. Robbie. Not right now, not at that. Maybe if we have time at the end of the period, we will. We've done quite a few of those. We'll do another one if we have time. Right now, we have got to forge ahead, and we are on note sheet number 13, or page 13. And we have this very strange shape. And we are going to do things to it. Alright, so here's the given. This is the given problem, my basic function, which I have named g of x. Notice it has a triangle, a semicircle, and a trapezoid. Alright, this is on page 13, this is number 4. Here we go. You're going to graph these on your graph paper. Okay? No, it's not awful, you just gotta remember the rules. So here we go. 2g of x. Now, I said this was nothing new, but I think it might be. Thank you, Asia. I think it might be a little bit of new stuff. Anybody have any idea? This is a little different. This number out here in front. Now, we talked about, if I put a +2 or something, we talked about that, right? But this is 2 times. Anybody have any guess what 2 times might do to the picture? It gets bigger. And actually, Morgan, it gets bigger this way. When you put a 2 out in front, this multiplies the height or the vertical. It multiplies the vertical of the problem. So what does that mean? Well, that means, okay, so this is A now, I'm graphing A, and you are too on your graph paper. That means, see this triangle right here? How high is that triangle right now? 2. It's going to get doubled. So now that triangle right there is going to go all the way up to 4. It is the same width, it's still over 2, but now it's all the way up 4. Now, let's do the next shape. The next shape is this circle right here, semicircle. How tall is he? In the original, how tall is that semicircle? 1. But because of this 2, he is now going up 2. It gets doubled. You multiply. So it was a 1, now it's a 2. So there's my semicircle now. We're multiplying the height. Okay, it was 1 tall, so now it's times 2. 2 times as tall. Now, how deep is this trapezoid? He comes down how far? 1. So we're doubling that, so now he's going to come down 2. So by golly, we did learn something new today. We learned that if there is a multiplier out here in front, it multiplies the height, the vertical of the problem. Now, let's look at B. B is -1/2 of the function. Okay, now wait a second. What does the negative do? That's old news. You're supposed to know that already. What does the negative do?
Upside down.
The negative turns it upside down. So this is going to go upside down. We just learned what the 1/2 does. What does the 1/2 do? It multiplies the height by 1/2. So this is multiplying the height, which means instead of this guy being 2 units tall, now he's only going to be 1/2 as tall and upside down. So if you can do that all at once, he's half as tall and upside down. So there would be my triangle. Half as tall and upside down. Half as tall, upside down. Now, our semicircle is going to be upside down. And how tall is he going to be? Our semicircle is going to be how tall? 1/2. How tall is he originally, kids? Look at your picture on your paper. He's originally 1. Now he's going to be half that. So he's going to be only 1/2 and upside down. So he's going to look like this. He's half as tall and upside down. Now what about our trapezoid? How deep was the trapezoid to start with? 1. So now he's only going to be 1/2 plus upside down. So he's going to look like this. Yeah, halves are hard. It's easier for me on the board. You got that graph paper, it's harder to do halves. You okay with that? All right, now I've got, oh boy. Now I have another multiplier, but you see how that 1/2 is in a different spot than this 1/2 was in? You see the difference? Okay, it makes a big difference. Any idea what that 1/2 is going to impact? That is going to change the width, the horizontal. But here's the tricky part. This number right here divides the horizontal. Now before you get totally confused, I want you to remember something. You remember how when you have the 2 hooked to the X, that it does the opposite of what you think? This actually goes left to. This one goes up to, but if it's hooked to the X, it's opposite of what you think. Same thing here. It looks like you're timesing by 1/2, but you're really dividing by 1/2. And dividing by 1/2 is the same as what? Multiplying by 2. So this picture isn't half as long, it is twice as long. See this little triangle right here? How wide is he?
2.
He's now going to be 4 units wide. He is the same height, but now he's 4 units across the bottom. He's twice as wide. This tells us to divide by 1/2, and dividing by 1/2 is really timesing by 2. So now I'm ready to do my semicircle. How wide is my semicircle? 2. Well, now he's going to be 4. Everything is doubled. Now, how wide is this trapezoid? Watch it. He's 1, 2, 3 units wide. Oh shoot, now he's going to be 6. I'm going to run out of room. Some of you aren't going to be able to see the end of it, but he's going 6 units that way. So everything is doubled. the same height. We didn't change the height, but we made him twice as long. Wow, that's a lot to keep track of. Now you think that's a lot. Look at D. Oh my land. Wow. And I better have a swig of coconut pineapple here before we try this guy. Oh. All right. Tell me what's going on. What does this 2 do? Pay attention to where it is. Where is it?
Makes it bigger.
It makes it twice as tall.
Yeah.
And I'm going to write that down. Twice as tall. A number out in front multiplies the vertical. There's a 2 out there. It's going to be twice as tall. Okay? Now, what does a number in here do? Whatever you hook to the X does what? Divides the horizontal. So this is going to take everything and divide it by 3. So it's going to be 1/3 as wide. It's divided by 3. All right, so here we go. Let's look at this triangle right here. How wide is that triangle? 2. But now he's only going to be 2/3 as wide. So he's only going to be that wide. There's 2/3. And how tall is he going to be? 4. Oh my gosh. So you've got a super skinny, tall, skinny triangle there. He's only 2/3 across the bottom now, because he used to be 2, but that got cut by 1/3. All right, what about our semicircle? How wide was our semicircle? 2. Now he's only going to be 2/3. So he's going to end there at 2/3. And he's going to be twice as tall as he was before. So he's going up to 2. Now what about our trapezoid? He was 3 wide. Now he's going to be 1. So he's going to end right here. And he's also twice as tall. We're going to have this very skinny little trapezoid. There we go. So what did we do? We made our picture twice as tall and 1/3 as wide. All right, somebody tell me what's going on here. Robbie? Okay, there's definitely a flip. How does Robbie know there's a flip in this problem?
Negative.
There's a negative. So then, but wait, you can't just say flip. You have to decide, is it going to be a flip sideways or is it going to be a flip up and down?
Sideways.
This is a sideways flip. So the location of the negative matters. When the negative is on the x term, that's a sideways flip. So that means when you draw it, the triangle will be on this side and the circle and the trapezoid will be on this side. What else happens? There's one other thing that happens besides the sideways flip. What else happens? What's that 2 right there do? It divides the width, or the horizontal, by 2, which means it's going to be half as wide. Okay, now again, if you can do this in one step, great. If you can't, break it up. I'm going to try to do this in one. I'm going to flip it sideways and make it half as wide. So what's going to happen to this triangle right here? He's going to the other side, and he's only going to be 1 across the bottom. So he's going to look like this. He's on the other side, and he's only 1 across the bottom. Oh, it's on, I said on the other side, and then drew it on the same side. Thank you, guys. Thank you. Got me all shook up here. He's on the other side and half as wide. Now, what about the circle? Well, he's coming over here, and he's only going to be 1 across the bottom. So he's coming over here, and 1 across the bottom. What about our trapezoid? He's coming over here. And wait a minute, how far is he going to be across? He was 3. So now he'll be 1.5. So 1.5, he's going to end here. And he's 1, yep. So there he is. So there we go. We did 2 things. We flip-flopped our picture this way, and we made it half as short, or this way, half as wide. Would you try F on your own? See if you can figure out F. There's a couple of things happening. Oh, F. Y equals negative G of negative X. What in the world did I do? Negative G of negative X. What's that going to do? Flip it both ways? All right, see if you can draw that. Take the original and see if you can draw it, flipping it both ways. I am going to do this in 2 steps. There is no way my feeble brain can handle it otherwise. In 2 steps. Maybe you could do it in 1, I don't know. You need to flip it over the x-axis and over the y-axis, both. does that picture look? Is that what you got? Anybody have a question about that? Does that look okay to everybody? All right, couple of more. Then we have one more new thing to learn, and then we'll be done learning new things today. All right, so next. We've got problem G, which says y equals 3g of 1/3 x. I should not have given you this on your graph paper. Tell me about this. Why is this going to be a problem for you to grasp? It is 3 times as tall, and that I think you can handle. But what else? It's 3 times as wide. This thing's going to be huge. So it's 3 times as tall and 3 times as wide. All right, so do your best or put it on a separate sheet of paper or something. This thing's going to be huge. All right, so 3 times as tall means that the triangle that was up 2 is now going to be all the way up 6. 1, 2, 3, 4, 5, 6. All the way up to 6. And he was 2 wide, but now he'll be 6 wide. You were making him 3 times, so he was 2, so now he's going to be 6. So here's my big triangle. He went 3 units taller, or 3 times as tall, and 3 times as long. So tell me about my circle now. What can you tell me about him? How tall will the circle be?
3
times by 3. So he's going to be 3 tall. How long will he be? 6. So he's going to be 3 tall and 6 wide. So there he is. 3 tall and 6 wide. What about the trapezoid? How deep will he be now? 3 down, but how many across? 9. Oh goodness. So there we are, finally. There's that picture. I'm sorry about the size, it's huge. Last one in this set. What's happening in this problem? Let's make a list. What are we doing? Twice as tall.
To the right 1.
Right 1.
Up 2.
Up 2. Perfect. Good job.
That's too much.
That's way too much. So this old feeble brain, one thing at a time. You do whatever you want. I'm going one thing at a time. First thing I'm going to do is pick up the whole shebang and move it right 2. Or right 1, I mean, right 1. So that picture is going to be reproduced exactly right 1. Okay, so my triangle, I am right 1. My circle and my trapezoid. There we are, right 1. All right, now I'm going to times by 2. I don't know that I've emphasized this, but let me do it now. Whatever is added on the end, I want you to take care of that last, okay? So if there's something stuck on the end of the problem, I want you to take care of that last. We're in our note sheets, Nick, if you want to get them out, please.
Okay. Thank you, Jordan.
Yes, I handed out earlier. Okay, so now I'm going to double it. So I'm going to do this, make it twice as tall. So I'm going to do that step in purple. I'm going to make it twice as tall. So my triangle's going to go up to here. My circle's going to go up to here. And my trapezoid's going to come down to here. So now it is twice as tall. I took care of this, twice as tall. I'm going to go ahead and get rid of the black one so it doesn't confuse you. So now I have taken care of the horizontal shift, right 1, and my vertical stretch, times 2. Now I have to pick the whole thing up 2 units. So I'll take every point and pick it up 2 units. So now this is going to go all the way up to here. So the green thing is the answer to the question.
What?
I can take the purple one out. That's too confusing. But one step at a time, I made my 3 changes that you told me about.
Isn't like the upside down like trapezoid view? Isn't it at 1?
Remember it got doubled, so it actually went down 2, and then it got picked up 2, so it's at 0.
Okay.
Because it got doubled. All right, now we're going to use the same picture for the next block of problems, but you'll notice the next block of problems involves what?
Domain. Or no domain. Absolute value.
Absolute value. So this is new to us, all right? How do I handle it when I'm told to take the absolute value? All right, so now I'm on part 5, and I'm going to sketch A, which is this. Now pay attention, this is new. I'm using the same picture, luckily, because I'm comfortable with that picture. I'm usually all this junk. Now here's what absolute value looks like. I'm going to go ahead and sketch it. You go ahead and sketch it, and then tell me what happened. All right, so this is going to be a picture of the absolute value. That is a picture of the absolute value. Now, can anybody explain?
Trapezoid is right side up.
What'd you say, Austin? Everything's positive. Isn't that what absolute value does? Make things positive? So if you've got a little negative thing down here, remember if you're underneath the x-axis, you're negative. If you got a little negative thing down here, what happened to him? He got made positive. Instead of having a negative trapezoid, now I have a positive trapezoid. What happened to my triangle and my circle? Nothing, because they were already positive. Positive means above the x-axis. So if you take the absolute value of the function, you take the absolute value, all it does is take whatever was down here and folds it up. So I'll make a little note so you can remember. Negative, or let's say, we'll even make it simpler than that. Bottoms get folded up. So anything that's at the bottom of the picture gets folded up. Now look at B, you guys. Can you see that B is a different problem? What's different about B? Where is the absolute value in B?
Yeah.
Around the X. This one, it was around the whole problem, right? Oh, Maddie, you okay? Now, if I'm going to graph the absolute value of X, just X, this is how it's done. Once you go back to your original picture, and anything that's on the right of the original picture, on the right side, I want you to redraw. So I'm going to redraw my circle, and I'm going to redraw my trapezoid. I want you to redraw the right side of your picture exactly as it is. Okay, so I'll wait for everybody to get that done, because the next step is wild and wacky. Now, I want you to take what you just drew and fold it across this way and redraw it on the other side. That is a picture of G of the absolute value. When you have the absolute value of just X, you redraw the right side of your picture exactly as it is, and then you reflect it onto the left side. So if you had a semicircle and a trapezoid over here, you have a semicircle and a trapezoid over here.
Should we erase the right side then? Or?
No, this whole thing is the picture. Now, you might be saying to yourself, whoa, Miss Ford, well, what happened to the triangle? He's gone. When you do this, anything on the left side disappears and it gets replaced with the new left side, which is the image of the right side.
Always that way?
Always. Always. All right, let's do C. The hardest part here, you guys, is going to be keeping track of where the absolute value is. So now we're on C. We're only going to do a couple more, and then I'll let you work on them on your O.
Got it.
All right, let's get this one done. All right, see where the absolute value is? Okay, so what does that position do? Absolute value there. The bottoms go up. Okay, so I'm going to draw that. So that'll be, let's get this one done, and then you can go. Time flies when you're having fun. Okay, so there's the absolute value part. The bottoms got folded up. Now what do I need to do? Move it up one. So I'm going to take this picture that I had, and everything is going to come up one unit. and the green is the answer to the question. Okay? All right. Have a great day. We'll pick up here tomorrow. I would anticipate homework being due sometime the very end of the week. Chris, you wanna?
So we wouldn't have class